In science, we do something called mole conversions, and really what a mole is just, it's also called Avogadro's number. It's just a number of particles or number of atoms that make up the atomic mass number of any particular element. Okay, so it is a really, really big number. So this is the number of atoms we need to make one atomic unit. Okay, so that is a lot of atoms there. Okay, so 10 to the 23 is like, I don't know, I don't even know the name for that word. So if I have this many or this many atoms of carbon, that gives me a mass of 12 grams, because that is the atomic mass of carbon. And the molar mass then becomes that mass in grams for 1 mole. So that many atoms weighs 12.011. We'll just say 12 grams. Okay, so 1 mole of carbon weighs 12 grams. So that's one of the equalities, that is, 1 mole equals this many atoms. Okay, so it's a measurement of the number of atomic particles. And it allows us also, this is a secondary part, it allows us to figure out the weight of certain elements when we have a standardized measurement of 1 mole. The other thing that a mole calculates is for gases. Okay, so it allows us to calculate the volume of gas at what we call STP, or standard temperature pressure. You don't need to worry about that because we'll just assume everything's right now is at STP. But standard temperature pressure means room temperature, sea level pressure. So 1 mole, or this many atoms of a gas, or this many particles of a gas, will occupy 22.4 liters of space. Okay, now if you compress it, it'll take up less space, but then they're changing the pressure. But at sea level, that's how many liters of space 1 mole of particles takes up. So here I'll give you some examples of these calculations. So here I have 2.5 moles of carbon dioxide gas, and I want to convert it to liters. So I don't need to worry about the number of particles, because I've been told the number of particles in moles. And I don't need to worry about the mass, because we don't need to worry about mass when we're talking about just liters. Okay, not for now anyways. So I'm going to have 2.5 moles of CO2. And then I'm going to have to use my conversion factor. 1 mole of CO2 is going to be 22.4 liters. Okay, so then I need to get rid of the moles of CO2, so I need to put that on the bottom. And that's equivalent to 22.4 liters of CO2. Okay, so these cancel out. Okay, so the moles of CO2 cancel out. We're left with liters of CO2 times on top, divide on bottom. It's just 2.5 times 22.4. So 2.5 times 22.4 gives me 56 liters of CO2 gas. Okay, now we're talking about liters of gas, so this is kind of assumed that we're talking about gas here. Okay, so there we have it. And again, we're using our dimensional analysis. Now we're just talking about, we don't need to worry so much about the notation here, okay, but we want to make sure that the moles of CO2 cancel out moles, cancel out moles.